All right, so today is a review of factoring to prepare us for what is coming. Oh my, oh my. So this is lesson 4.4, and we are looking at factoring. So factoring is the process used to rewrite an expression as the product of its factors, something times something. The common factor of each term of an expression that has the greatest coefficient and the greatest exponents is called the GCF, or greatest common factor. The GCF for 4x cubed plus 20x squared minus 12x is, so if you look at the numbers 4, 20, and 12, the biggest number that they can all be divided by is 4. Then look at their variables. This has 3 x's, 2 x's, and 1 x. The most x's that you can take away from all three of them and take the same amount is just 1 x, because this one only has 1 to give. I can't take 2 x's from it because it only has 1. I can't take 3 x's because it only has 1. So I can divide each one of those by 4x, and that would be that greatest common factor. Then a trinomial, that is the square of a binomial, is known as a perfect square. Trinomial. And this is an example of a perfect square trinomial. Here are some things that you're going to be looking for, and we'll talk about this a little closer. Well, when we get into the lesson, we'll talk about it more. But notice that this is a perfect square, 25 and x squared. This is a perfect square. We're going to talk about how you know that this is the right middle term. So if you determine that this is a perfect square trinomial, you will take the square root of this term, which is 5x, and put it here. And you will take the square root of this term, which is 3, and put it here. Whatever the sign of the middle term is will go in the middle of the binomial, and then we square it. So that actually has a pattern, and we will look at the pattern. You'll write the pattern down in one of your next sheets. Then another favorite factor pattern is this a squared minus b squared, and it's known as the difference of two squares. Okay, and it can be factored, and this is its pattern, into this. So if you have the difference of two perfect squares, it will be factored into this plus minus pattern, which we've actually done quite a bit of work with. And then, for instance, see how we have the difference of a perfect square and a perfect square. So the square root of 36x squared is 6x, so 6x and 6x. Square root of 25 is 5, 5 and 5, and then a plus minus. So you will hear me using the word FOIL, or double distribute. FOIL is just a mnemonic for using the distributive property twice. That's why I'll also say double distribution. So F is for first. O is for outer. I is for inner. And L is for last. So if I'm multiplying a binomial times a binomial, like we'll use this difference of two squares, these are my first terms, so they're going to be multiplied first. Then my outer terms would be here. So that would be my outer, so that's my first distribution. First, outer. Then we're going to do the inner. So my inner terms would be here. And then my last terms would be here. So that second distribution is going to be inner and then last. All right, so let's look at how do we factor a trinomial that has a coefficient in front of the x squared and that coefficient could be positive or negative. It doesn't matter. So we're going to talk about that. So the first thing we're going to do is, if there's something in front here, we're going to multiply it to this term here. So I like to call that my bookends. So we're going to multiply the two bookends together. Well, all four of these really don't have a coefficient. So it looks like we're not really multiplying, because 1 times 40 is 40. So you take that product and you're going to put it over here in the table. So I have a positive 40. Because that product is positive, we are going to add the factors of 40, and we are going to look for positive 14. So my factors of 40 are 1 and 40. Those two add to give me 41. 2 and 20. They add to give me 22. 3 does not go into 40. 4 goes in there 10 times, and that's 14. 5 goes into 40 8 times, and that's 13. 6 does not go into 40, and 7 does not go into 40, and that brings us back up to this 8. So those are all of my sums. Notice that this is the one that adds to give me 14. And so now I have to figure out my signs. The sign of my middle term is positive, so 100% of the time, the bigger of the two carries that same sign. For 4 to combine with 10 to make 14, it better be positive as well. So once you determine the signs, then you can put them in the parentheses. So x squared becomes x and x, and then you're going to put your plus 4 and your plus 10. And as you can see, we're going to FOIL first x squared, there you go. Outer is 10x, inner is 4x. So the 10x and the 4x add to give you 14x. And then last, 4 times 10, 40. So this does work. So I want you to practice that method with the rest of these. So pause the video and practice. Okay, so again, I'm just really multiplying 1 times 30, and that's giving me a positive 30 for that product. And I'm looking for my middle term, which is negative 11. So because my product is positive here, it means I'm going to add the factors of 30. So my factors of 30 are 1 and 30, which is 31. 2 goes into 30 15 times, which is 17. 3 goes into 30 10 times, which is 13. 4 doesn't go into 30. 5 goes into 36 times, and there's no more numbers between 5 and 6. And that finally adds to give me 11. So this is what I'm looking for. And then my middle term should be 11, or negative. The bigger of the two terms carries that same sign. The 5 is going to have a sign of negative as well to make negative 5 and negative 6 negative 11. So then you can throw them into parentheses. The x squared becomes x and x. And then you have your minus 5 and your minus 6. And you can refoil that to check if you'd like. I'm not going to take the time here. Then look at C. So for C, I'm going to take 1 times 21, and that's going to give me a positive product. So that means I'm going to add, and I'm looking for positive 4. So 1 and 21 add to give me 22. 2 does not go into 21. 3 goes in there 7 times, and that adds to give me 10. 4 does not divide into 21, neither does 5 or 6. And so we finally reach back to 7. So those are all the factors of 21. Not one of them added to give me 4. Now these two subtract to give me 4, but we have to add. Because this product was positive, we have to add. Otherwise, if you make it subtraction, your signs will not work out. You will not get a positive 4x here. So, because none of our sums was our middle term, this is considered prime. It is not factorable yet. All right, now D poses a problem. All right, so for this problem to work, we're going to need to, especially with this particular method, we're going to need to rewrite the terms from highest degree to lowest. In other words, the proper order that they're supposed to be in. We typically have the x squared term first, and then the x term, and then the constant. But we need this to be positive. So we're going to factor out a -1 from each of these and pull a -1 out in front. And that now gives us a positive x squared, a -5x, and a -36. So I'm going to ignore the -1 for right now, and I'm just going to factor this. So I'm going to multiply 1 times -36. That gives me a -36. So that means that I do not want to add the factors of 36. I want to subtract them, so I want a difference. And I'm looking for a middle term of -5. So my factors of 36 are 1 and 36. They subtract to give me 35, so that's not it. 2 and 18. They subtract to give me 16, still not it. 3 and 12 subtracts to give me 9, nope. 4 and 9 subtracts to give me 5, and there it is. So those are the ones I'm looking for. But my middle term is currently negative after we've factored out the -1. So the bigger of the two, the 9 gets that negative. The 4 is going to have to be positive in order to combine with the -9 to make a -5. And so now we can put those in parentheses. The x squared becomes x and x. And then you're going to put in your +4 and your -9. And that should now work. So there's your final answer. Okay, so let's look at greatest common factor. Oops. Let's erase the line I just put in there inadvertently. Greatest common factor. All right, so the very first question you should always ask yourself, is there a GCF? Even if you can factor it without taking out the GCF, you need to factor out a GCF, because otherwise your final binomials are not going to be fully factored. So as you look at the 7 and the 21, they were both divisible by 7. So I'm going to divide by 7, divide by 7. They do not have any variables in common. So these 7's cancel and you get an n squared. -21 divided by 7 is -3. Then you have to look inside here and see, can this be factored? The only binomial that you can factor is the difference of two perfect squares. Well, I have a difference. N squared is a perfect square, any even exponent is, but 3 is not. So because the 3 is not a perfect square, we are done. This is your final answer. So let's look at B. So for B, if I look at the numbers, each of these numbers are divisible by 9. And so I'm going to take a 9 out in front. They do not all have a variable in common. These do, but this one doesn't, so I cannot factor out an x. So the 9 is going to go in front of parentheses. And these 9's cancel, you get an x squared. These 9's cancel, you get a plus x. -18 divided by 9 is -2. Then look in here and see, is this factorable? Are there factors of 2 that subtract to give us 1? Well, yes, there are. So are there factors of 2 that subtract? So because the 2 is negative, so we're going to subtract to get us +1. Well, 1 and 2 subtract to give you 1. And your sign for your 1 is positive. So the 2 is positive. The 1 is going to have to be negative. So that means I cannot forget about that GCF. So notice that it just came out in front. The x squared becomes x and x. And then we're going to put in a -1 and a +2. And then just make sure that these are not the difference of two squares, which they're not. So we are done. That's our answer for this one. Okay, look at C. So I want you to factor C and D on your own and see how you do. So pause the video and try it on your own. Okay, so as you look at the numbers, each of these are divisible by 4. So we're going to pull a 4 out in front. That leaves me with an x squared. 8 divided by 4 is 2x. 12 divided by 4 is plus 3. So then look here to see if it's factorable. Are there factors of 3 that add to give you 2? There aren't. Factors of 3, because the product is positive. 1 times 3 is positive. Factors of 3, so we're going to add, and we're going to look for positive 2. Well, there's only one set of factors for 3, and they only add to 4. They subtract to give you 2, but we have to add. So the inside is considered prime. This is prime here, but this would be your answer. Then for D, I know that I can divide each of these by 9, and they do not have a variable in common. So then I get 18 divided by 9 is 2y squared. The 9's cancel, and I get plus y. Negative 27 divided by 9 is negative 3. So then this time I want to multiply the 2 in front to the negative 3. So I'm doing 2 times negative 3, and I get negative 6. Because my product is negative, I'm going to find the difference or subtract. And I'm looking for a middle term of positive 1 because that's the coefficient in front of the middle term. So the factors of 6 are 1 and 6. Those subtract to give me 5, so that's not it. And then 2 and 3 subtract to give me 1. So there are factors of 6 that subtract to give me 1. And so those are the ones I want. So my 1 is positive. That means the bigger of the 2 is positive. The 2 is going to have to be negative to create a positive 1. So don't ignore the 9, it stays there. But then the trinomial breaks into, we are going to do, so let me back up just a smidgy step. So when we multiplied the 2 by the negative 3, we actually changed that trinomial so it looks like this. 9 times y squared plus y minus 6. So we're actually factoring that trinomial. So we're going to do one more step to make it right. So here the y squared becomes y and y, and then the negative 6 we're getting from these two terms. So we're going to get a minus 2 and a plus 3. But if you recall, if I have a coefficient in front of the squared term that I multiplied by to get a new trinomial, I have to go back that out and divide those by that 2. So because we multiplied by this 2, I am dividing these by 2 to reverse what I did. If 2 goes in there evenly, great. If it doesn't, it pops up in front of the variable. So 9 times y minus 2 divided by 2 is 1. And then in this case, the 2 does not divide into 3, so it pops up in front of that y. So you get 2y plus 3. You're done. All right, so what happens when you have a coefficient in front? Well, we just kind of talked about that. So let's go through that process. We just talked about that. If you want to, you can pause the video and try these 3 on your own and see what you get. I'm going to run through it really quickly. So we're going to multiply the 4 times the 3. That's going to give us a new trinomial, x squared plus 7x. 4 times 3 is a positive 12. So that means that our product of 4 times 3 was a positive 12, meaning we're going to add because it was positive, and we're looking for the middle term of positive 7. So I've got 1 and 12 add to give me 13. 2 and 6 add to give me 8. 4 and 3 add to give me 7, and that's what I'm looking for. My 7 is positive, so the bigger gets the sign, and the 3 had better be positive to make a 7. So then I've got my binomials. The x squared becomes x and x, and then you're going to put your plus 4 and your plus 3 in. But we're not done, because remember, x times x is not 4x squared. We have to go back and reverse out multiplying by this 4. So I'm going to reverse it out by dividing by 4 and dividing by 4. And so I get x plus 1, because 4 divided by 4 is 1. But here, 3 is not divisible by 4, so it pops up. And I get 4x plus 3. All right, then for B, same thing. I'm going to lasso this 2 and multiply it to the 6. That gives me positive 12. So x squared minus 7x plus 12. Because my product of 2 times 6 was positive 12, we are going to add the factors of 12 to find a negative 7. So 1 and 12 gives us 13, 2 and 6 is 8, and 3 and 4 is that 7. So it's very similar to the last one, but this time my middle term is negative. The bigger of the 2 carries that sign. The 3 had better be negative in order to make a negative 7. So our binomials, the x squared becomes x and x, and then you're going to put your minus 3 and minus 4. Then remember, we multiply by this 2, so we have to back it out by dividing. So I'm going to divide by 2, divide by 2. And so I get, this 2 doesn't divide into the 3, so it pops up. So I get 2x minus 3. Negative 4 divided by 2 is negative 2, so x minus 2. And finally, let's look at C. So I'm going to lasso that 3 and multiply it to the 4. And good gracious, we have 12 again. So we get x squared minus 8x plus 12. So our product was 3 times 4, which gave us a positive 12. Because the product is positive, we're going to add the factors of 12, but I'm looking for a negative 8. So 1 and 12 add to give you 13. 2 and 6 add to give you 8. So there it is. I want my 8 negative, so the bigger carries the sign. The 2 is going to be positive. So we're going to throw that in the parentheses. X squared becomes x and x. And then you put in your plus 2 and your minus 6. But we can't forget to back out this 3. So we're going to divide by 3, divide by 3. This 3 does not divide into the 2, so it pops up. So I get a 3x plus 2, and negative 6 divided by 3 is negative 2, so I get x minus 2. So let's look at some factor patterns. Factor patterns will save you time. So let me make this one a little smaller. We'll look at these separately. So the first factor pattern, as I promised, is the difference, I'm sorry, not the difference, it's the perfect square trinomial. So for a perfect square trinomial, you're going to have to test your trinomial to determine, is it a perfect square trinomial? Now the factor pattern that we're going to be looking for is parentheses a plus b squared for this one. And for this one, it's going to be parentheses a minus b squared. So how do you know which is which? Well, The middle term is positive, so the middle sign here is positive. The middle term here is negative, so the middle sign here is negative. Now, I'm just going to work with this one, but it works the same with the other one. So how do you determine if a trinomial is a perfect square trinomial so that you can factor it using this pattern? Because that way I don't have to do a table of values. Because as I look at this trinomial down here, I would have to multiply 25 times 4, which is 100, and I would have to add the factors of 100 to get to 20. And then I would have to divide back out that 25. So you can be some really big numbers. I mean, if you look at, that one's not too bad. This one's going to be oops. Let's see if I can get out of what I just did. So this one's going to be a fairly large number. You're not going to have to factor that. So here's a suggestion. You're looking for two things. Thing one, look at your bookends. That's your first and last term. Are these bookends perfect squares? Pay attention to the variables and the coefficients. 25 is a perfect square. X squared is a perfect square. Any exponent that's even is a perfect square. And 4 is a perfect square. And then on top of that, they both have to be positive, which they are. Then I need to test this middle term and see, does it match this pattern of 2ab? Well, how did they come up with this 2ab? The square root of a squared is a. That's where the a comes from. The square root of b squared is b. That's where the b comes from. And then we're going to multiply it by 2. And really the purpose of this is because when you FOIL a squared binomial here, a plus b times a plus b, your inner and outer terms are both identical, so you have two terms that are the same. So here we go. I have identified that I have perfect square bookends, so what I'm going to do is test for 2ab. I highly suggest you write it down and don't do it in your head because you can get tricked. So 2 times a, I'm going to take the square root of a squared because this is your a squared here, right? So the square root of 25x squared is 5x. And then b is going to be the square root of this one because this is b squared. And then that one here is 2. So then you're just going to multiply it together. 2 times 5 is 10. 10 times 2 is 20 times the x is 20x. And you're like, okay, it doesn't match by sign. We don't care about the sign. We'll make the sign work. So just look at the absolute value of this and compare it to this. It matches. So matches. As soon as it matches, you know that it has this factor pattern. Every term in this trinomial is going to contribute to this binomial here. So we're going to take the square root of this and put it here, the square root of this and put it here, and then the sign of the middle term gives us the middle sign. We've already taken the square root of these. It's this one and this one. So I'm just going to take these and put them there. So I'm going to get a 5x here and a 2 here. Then the middle sign is going to come from here. Middle sign is negative, so the middle sign here is a negative. And so this is your factoring. Of number A. Okay, so let's look at another one. So this is a new one. So you want to look at the bookends. Is this a perfect square? Yes. Is this a perfect square? Yes. Is this a perfect square? Yes, because square root of 1 is 1. So we need to test the middle term to see if it matches the pattern of 2ab. So I'm going to take the square root of the bookends. All right, so I've got 2 times. The square root of 64x squared is 8x. The square root of 1 is 1. So 2 times 8 times 1 is 16 times the x is 16x. And it matches. It doesn't match the sign, but as I said, we'll fix the sign. So as soon as it matches, you know that this is the pattern. So this is going to go here. This is going to go here. So I've got an 8x here and a 1 here. And then that middle sign right here is going to go down in the middle. So our middle sign is a negative. So this becomes your final answer. Now you try the last one on your own. Right there. You got this. So I have a perfect square and a perfect square and a perfect square. So all I have to do is test for this, and I'm going to test it to see, does the middle term come out to be 2 times a times b? So I'm going to take the square root of a squared and the square root of b squared. So I have 2 times okay, so the square root of 4x squared is 2x, and the square root of 49 is 7. So 2 times 2 is 4, 4 times 7 is 28, times the x is 28x, and so it matches. So immediately, this is the factor pattern. So these are going to go here. So I've got a 2x here and a 7 here, and then the sign of the middle term is going to come down there in the middle to be a plus. That's all there is to it. Learn those factor patterns. The next factor pattern is the difference of two squares. One of my favorites is one of the easiest to factor. You have the difference of two perfect squares. As soon as you have that, and we've done a lot of work with this one, it's 2 sets of parentheses. Oh, hang on, let me move some stuff around. And you're going to have a plus minus pattern. So the square root of a squared is a, and the square root of b squared is b. And that's it. So you're going to have an a plus b and an a minus b. So let's look at some examples here. So let's start with a. So you cannot factor as a difference of two squares unless you have the difference of two squares. So here I have a difference. This is a perfect square, this is a perfect square, this is a perfect square. If this were a plus, I wouldn't be able to factor it. I cannot factor the sum of two squares. No matter how hard you try, it's not going to work out. So here we go. I do have the difference of two squares, so I know that my factor pattern looks like this with a plus minus. So I'm going to take the square root of these, and they're going to go inside. So the square root of 16x squared is 4x, and 4x. The square root of 81 is 9 and 9. Now the only thing you have to watch out for is that you look in these binomials to see, do you have the difference of two squares again? So, and I always put the plus in front of the minus because this one you could never, even if it were the sum of two squares, as I said before, you cannot factor the sum of two squares, so that's not going to factor anymore. Here I have the difference. 4 is a perfect square, but x to the first is not. So it doesn't matter that 9 is also a perfect square. If that were x squared, then you could factor this one again in a plus minus pattern. But it's not, so you can't. So this is your final answer. All right, so let's look at B. Actually, I want you to do B, C, and D on your own, and then restart the video. So pause the video, do B and C and D on your own. Okay, so this is the difference, perfect square, perfect square, perfect square. So it does meet the qualifications for the difference of two squares. So I know I have a plus minus pattern. The square root of 25x squared is 5x. And the square root of 36 is 6. This cannot be factored any further. I do not have the difference of any squares, so that's it. Let's look at C. So for C, don't forget that 1 is a perfect square, 9 is a perfect square, and anything to the even power is a perfect square. So this is the difference of two perfect squares. So it meets the qualifications for the pattern. So I got a plus minus. The square root of 9m to the fourth is 3m squared. 3m squared. The square root of 1 is 1 and 1. So then you want to look, can I factor this any further? Nope, 3 kind of kills it. M squared is a perfect square, and 1's a perfect square, but this is not. So we are done with that. The last one, I have a perfect square, and a perfect square, but this right here is not the difference. So this is not factorable. except for the fact that 36 and 9 do have a common factor, don't they? It's 9. So we're going to factor out a 9. So it's not really fully prime, it has a GCF. So if there's a GCF, you have to factor it out. So I can divide that by 9, divide that by 9, and take a 9 out in front. 36 divided by 9 is 4x squared. 9 divided by 9 is 1. So now I have, again, perfect square, and a 1, but that plus keeps me from factoring it further. So this is as far as you can go. It's a little tricky. All right, so then the last 4 are any of the different methods that we've discussed already. So I want you to pause the video. I want you to try the 4 methods. They're all mixed up. You could have a perfect square trinomial, the difference of 2 squares, just a GCF mixed with something, or one of our trinomials. So go ahead and try it and then restart the video. Okay, so the first question you should always ask yourself, is there a GCF? No matter what. So 4, 20, and 12 all can be divided by 4. So I'm going to start there. Then we have an x squared, an x, and an x. So the most x's that I can take away from all 3 of them and take the same amount is 1x. Then we have a y squared, and a y. The most y's I can take away from all 3 of them and take the same amount is just 1y. So then that 4xy is going to come out in front of parentheses. I'm going to divide. So the 4's cancel. X squared divided by x is x, and the y's cancel. Negative 20 divided by 4 is negative 5. The x's cancel. Y squared divided by y is y. 12 divided by 4 is 3. And the x's and the y's cancel. And so, make that shorter, that's our answer. Then you do want to just double check, can this be factored further? Nope, not at all. So this is, you're gonna just have that as your final answer. So let's look at B. So for B, you want to ask yourself again, is there a GCF? Number-wise, they don't have anything in common, but they all have an M. And the most M's that I could take away from all of them and take the same amount is 1M. So I'm going to have an M come out in front. That leaves me with M squared minus 9M minus 10. So then you want to ask yourself, there's no, so ignore all this for right now. So I'm just looking at this black trinomial. The coefficient here is 1, so 1 times negative 10 is negative 10. So are there factors of 10 that subtract to give us 9? Well, let's see. So I multiplied 1 times negative 10, and I got negative 10. So because 10 is negative, we're going to take the difference, and we're going to look for a negative 9. 1 and 10 subtract to give you 9. There it is, first try. So my 9 needs to be negative. The bigger always carries the sign. The 1 had better be positive to make that negative 10 a negative 9. So I'm going to bring down the GCF of M. You cannot forget about that. And then break this into my 2 parentheses. I realize that's like a terrible M. There we go. So the M squared becomes M and M. And then the plus 1 and the minus 10. And if you look into your binomials, these cannot be factored any further. So this is your final answer. All right, for C, I'm looking for a GCF, nothing with the numbers, and they do not all have an X. So this one does not have a GCF. Then the second question, is it a binomial, meaning 2 terms? No. Is it a trinomial? Yes. Is it a perfect square trinomial? Nope, I don't have perfect square bookends, so we're going to have to factor it using this swing method here. So I'm going to multiply the 2 to the 5, and that's going to give me x squared plus 11x minus 10. So my product is negative 10. That means we are going to find the difference because my product's negative, and I'm going to look for positive 11. Are there any factors of 10 that subtract to give me 11? There's factors of 10 that add to give me 11 because I've got 1 and 10. But remember, my product here is negative. So I got to find the factors of 10 that subtract to give me 11. Well, 1 and 10 subtract give me not, whoops, that's the wrong one. They subtract to give me 9, and then the only other factors of 10 are 2 and 5, and they subtract to give me 3. So it's really important that you really understand, am I adding the factors here or subtracting them? So again, because that product was negative, we are subtracting them and not adding. So this one is not factorable. So our answer is prime. All right. Excuse me for coughing. Last one, D. So for D, looking for a GCF, 2 and 32 have a 2 in common, but they have no variables in common. So I'm going to divide each of them by 2 and pull a 2 out in front. That leaves me with x to the 4th minus 16y squared. Then look inside, can you factor this? It is the difference of 2 perfect squares. So yes, it can be factored. So I'm going to bring down the 2, but the binomial meets the difference of 2 squares factor pattern, and that pattern for this is going to be a plus minus pattern. So we're going to take the square root of x to the 4th, which is x squared, and the square root of 16y squared, which is 4y. Then you want to look again. That can't be factored, it's a sum. This is the difference. Here's a perfect square, here's a perfect square, but the y kind of messed it up. The y is not a perfect square, so we are done. This is your factoring to D. All right, so go try your homework. Be strong factors. Ask me questions if you get stuck.